So probability trees, which are the funniest things in the world. Well, not really, but they're kind of straightforward, aren't they? But they can get a little tricky, which is what we're going to do today. We're going to look at dependent events. Last time we were doing independent events, and from one event to the next, the probability didn't change. The probability of the second event isn't affected by the first one, but now, of course, it's going to be. So the outcome of the second event depends on the outcome of the first event. The probabilities will be affected by that. And so some examples could be, we quite often pick counters from a bag, don't we? Mathematicians love buying lots of watermelons, different sizes of packs of toilet paper, and picking counters from bags. It's what we do. But this time, say we take a counter out and we don't put it back in again, there will be a different amount of counters in the bag. So the probability is going to change because it's, the fraction's out of a different amount. Same with, eating biscuits from a tin. You take a biscuit randomly and then eat it. Obviously, there's going to be less biscuits in the tin, so when you take the next one randomly, it's going to have a different probability. Or choosing a card from a deck of cards. If you don't replace it and then choose another one, the probability is going to change because there's a different amount of cards. But it will depend which card you got the first time as to what the probabilities will be the second time. Or with the biscuits, depends if you got a bourbon, the amount of bourbons has changed. Or if you got a Garibaldi biscuit, yes, it is a biscuit, then the amount of those is going to change. The main thing here is usually that we're talking about if you select one item and don't replace it before selecting another, then these are definitely going to be dependent events. There are other versions, but these are the ones that we usually encounter. So let's look at an example. That's the best way to do it. We're going to have a box and it's going to have 8 milk chocolates in it. Milk chocolates. Or 4 plain chocolates. Plain chocolates. And Linda is going to choose a chocolate at random because Linda's a bit like that. And she's going to eat it and then choose a second. And we want to know what the probability is going to be of getting each. It's going to be totally at random, so what's the probability of getting 2 milks or 2 plains or whatever. Okay, so let's start off. Now the probability tree always starts in the same way. So we've got 2 options, and we've got milk, and we've got plain. And what's the probability of getting a milk? Well, there's 8 milk and 4 plain. Now altogether there are 12 chocolates at the start, so the fraction will be out of 12, and there are 8 milk, so it's 8 out of 12, and there are 4 plain, so that will be 4 out of 12, and that adds up to 12 out of 12. So our set of branches is fine. Now, let's say that we then take a second chocolate. She's taken that chocolate, whatever it was, and she's eaten it. Now there's going to be less chocolates, and we have to imagine what has happened. This set of branches at the top will have different probabilities to this set of branches at the bottom, because the top set of branches on this journey, she took a milk chocolate, so there's 1 less milk chocolate. But on the bottom set, she took a plain chocolate, so there's a different amount of plain chocolates. So you have to think about what has happened before to change the probability on this second set of branches. So the options are still the same, because I can still get milk chocolate, or I can get a plain chocolate. And let's have a look. Let's go up this way. So this way we've gone up and we took a milk chocolate. So if we've ended up on these branches, we've taken a milk chocolate. So there are now no longer 8, because she ate it. There are now 7 milk chocolates out of how many? Well, if there's 7 milk, there's still 4 plain. There's basically just 1 less chocolate, isn't there? So it's 7 out of the 11. But on this branch, she took a milk chocolate. So what happened to the number of plain chocolates? That didn't change. So she's still got 4 of them out of the 11. It's still out of 11 because her chocolate's gone. It was just milk chocolate, not plain. So that's the top set of branches. Let's do the bottom set of branches. Now we've got 2 options, which are milk and plain. Now, if we've ended up on these bottom branches, we've obviously come down this route. That means that we've got a plain chocolate. We had a 4 in 12 chance of getting it, and we got that. So we've got a plain chocolate. That means there's 1 less plain chocolate. So instead of 4, because she ate it, there are now 3. out of 11, because there's obviously one less chocolate again. But the milk chocolate, well, if we ended up on this set of branches, we've eaten a plain chocolate, not a milk chocolate, which means there are still 8. And it's out of 11. And check these out. 8 plus 3 is 11. That would be 11 elevenths. Same up here, 7 and 4 also makes 11 elevenths. So my probabilities have changed. And that is the only difference with dependent events. It's a big difference, but it's the only difference. So you have to keep in mind on your set of branches what has happened before and how that affects the outcome. Okay, so let's calculate the probability that Linda gets 2 milk chocolates. Well, that would be going up here and up here. It would be this journey across. Remember, we said when we go along the branches, we multiply. When we go down the branches, we add if we need to. But so let's go along. So I've got 8 out of 12 times by 7 out of 11. Okay, so to get to this point, I would have done, we do 8 times 7. Oh, it's 8 sevens again, isn't it? It's 56. I have a real blank with 7 8s and 6 8s. But it's 56. And then 12 times by 11 is 132. Okay, so 56 out of 132 is my first answer. There we go. So calculating the probabilities ends up the same. The only thing that's different is that you have to think about the probabilities, how they've been affected by the first choice. And then the second question is one of each. Okay, so this is another one of those where we've got 2 possible answers, isn't it? And we've got 2 possible routes. We've got milk chocolate and then plain. So that would be my 8 out of 12 times by my 4 out of 11, which would be 32 out of 132. Or I might have got a plain and then a milk. So it's this journey as well, which is 4/12 times by 8/11. Those are the 2 probabilities on that journey to get there, which is also, weirdly, 32 out of 132. Now to answer this, remember, when we go down the probabilities, if I need more than one probability, I need to add them together. Along the branches we times. If we're going down the end, we add. So we're going to add 32 out of 132 and another 32 out of 132, which is 64 out of 132. Right? Get the idea? Good, of course you have, because you're awesome. Awesome people. Look at this question then. There's a bag and it's got some counters in. 2 black, 3 white. A bag contains 5 counters. 3 black. No, I can't read. 3 white and 2 black. I even just said 3 white and 2 black, and for some reason I can't read. So that's what it's got. 1 counter is selected and not replaced. So we know that this is going to be a dependent event. The outcome, the second event, taking the second counter, will be affected by what counter you get the first time. Work out the probability that the counters will be either the same colour or different colours. And we've got some sets of branches. And I want you to do this one. So I want you to write this one out, please. Press pause, write out the probabilities, do the tree first of all, and then do the, calculate the questions you got there, the probability of the same colour and different colours, and then unpause. We have unpaused. Okay, what are my 2 options? We have got either white or black. Okay, and what's the probability of getting white? Well, remember the first set of branches are quite straightforward, aren't there? There are 3 white out of the 5 counters, and there are 2 black out of the 5 counters. And let's say that we've gone along and we're going to do this top set of branches. Now, if we do this top set of branches, what happened in the first event? Well, we picked out a white counter. Okay, so there is going to be 1 less white counter. So instead of there being 3, I've picked 1 of them. So there's now only 2 of them. Out of, how many counters are there? Well, I've taken 1 out. There's no longer 5. There are 4 counters. But how many black counters are there? Well, there's still 2 because we haven't taken any. We came up this journey, which meant we took a white counter, not a black. And that's out of 4. So it's 2 out of 4 and 2 out of 4. But let's do the bottom set of branches. My 2 options are white or black. Let's say that if I end up on these branches, basically I've taken a black counter out. That's what happened the first time. Took a black counter. There's now 1 less black counter. So instead of being 2, There's now 1, isn't there? Out of how many counters? Well, there's no longer 5. There must be 4. But how many white counters? Well, if I end up here, I haven't taken a white counter. I've only taken a black counter, which means there are still 3 white counters. You have to sort of get your head around this. Out of the 4. And look, just double check, 3/4 and 1/4, they add up to a whole, don't they? So I've definitely got it right. Now let's do the probabilities then. What's the probability of the same colour? Well, that would be, there's 2 options for this, white, white, or black, black. So the white, white one will be 3/5 times by 2/4, because that's the journey to get here, 3/5 and 2/4. That would be 6/20. Multiply the tops, multiply the bottoms. Or black, black, that's my other option. So 2/5 times by 1/4. Multiply the tops, multiply the bottoms, 2/20. And so to answer A, I need to add those 2 options together, because remember, when you need more than one option, you need to add them together. Just put them together. And that is 8/20, or anything equivalent to 8/20. Right, let's change colour. Let's go for that really sickening, horrible magenta. What about different colours? Well, there's 2 options for different colours. There's this one with white and black, which would be 3/5 times by 2/4. Or there's this one, black and then white, which would be 2/5 and then 3/4. 3 times 2 is 6, 5 times 4 is 20. So that's the probability of that outcome. And the probability of this outcome is 6/20. And so I need both those particular options, because they both end up with the person having different coloured counters. So we add the 2 fractions together. 6/20 and 6/20 makes 12/20. Yeah, well done if you got that one. Let's do another example. Now this one's slightly different, so let's read it together. 2 boxes contain black and white counters as shown. I don't know why it says boxes. In fact, I'm going to cross that through, because it's clearly a bag. But I am going to go back to the blue pen, because I don't like the magenta. There we go. Bag A and bag B, and they've got different amounts of white and black and white counters. Now bag 1 has 2, or bag A, sorry, 2 black and 1 white. Bag B has 2 black and 2 white. What's going to happen here is a counter will be picked from bag A. Well, that's pretty straightforward. And placed into bag B. So they're going to pick a counter. We can work out the probability of what they're going to get. Then that counter is going to be put into this counter. And then they're going to choose a counter from this bag. So it depends what was chosen the first time as to how many are in the second bag. Okay, sneaky little question, this one. So what's the probability that the counter will be white? And when they say white, they mean not white from the first bag, but once we picked a counter out, put it in the second bag, we pick that counter out of B, what is it going to be? Is it going to be white? What's the probability? Okay, there's some sets of branches for you to think about. I want you to press pause. I want you to do the tree and then work out what's the probability that that second counter picked out of B will be white. Off you go. We have unpaused. Let's have a look. Well, what are my options? Well, from bag A, we're going to take a counter out of bag A, and it could be black, and it could be white. And the probabilities are straightforward. There are 2 black out of 3 counters, and there's 1 white out of 3 counters. So 2/3 and 1/3, that adds up to a whole, doesn't it? So that's good. Right, let's imagine we've got taken this route, we've taken the black counter out of the bag, and we've put it into bag B, and we're going to pull a counter out of bag B. And so if we're on this set of branches, we've taken a black counter out and we've added it here. So we've now got an extra black counter. So there will now be 3 out of, well, there were 4 in there, but we've put 1 in. So there's now 5 counters in there. And how many white counters? Well, we haven't added any white counters if we're on this set of branches. So there's still 2 out of the now 5 counters. 3/5, 2/5, that makes a whole, doesn't it? So that's good. Okay, bottom set of branches. So this bottom set of branches, we could then get a black and white, obviously. If we come down here, we have picked the white counter, the 1 white counter out of that bag and put it into B. So there is now 1 more white counter. So there are now 3 white counters out of the 5 counters that are now in there because we've added a counter to bag B. Yeah, we took the white one, we added it to B. But there's still only the 2 black counters out of the 5 counters that are now there. 2/5, 3/5, that adds up to a whole. What's the probability that the counter will be white? I'm going to go back to red, strong red pen. What's the probability that the second counter is white? Well, there are 2 options. This one, where we pull a white out of the second bag, or this one, where we pull a white out of the second bag. So 2/3 times by 2/5 equals 4/15, and 1/3, because we got the white there, times by 3/5 is 1 times 3 is 3, 3 times 5 is 15. And so our probability, the answer that we want, is going to be, so the probability of getting a white on the second time you take it out will be those 2 probabilities added together. 3/15, 4/15, oops, equals 7/15. Now, really well done if you got that. Well done if you got the tree. If you didn't notice that there were 2 options for the ending, well, never mind. But as long as you know how to work out the probabilities and keep it in mind for next time. Okay, what I want you to do next then, that was a slightly shorter one than yesterday. There's a My Maths task to do. Have a go with it. If you're really stuck, obviously get hold of me. Otherwise, good luck.